Now, for evaluating algebraic expressions, you guys, this is a pretty crucial skill in mathematics. Not only now, but I mean, you'd be using this up in the 1010 at least. I mean, it's a very crucial skill. So here's our first problem. Just try this one out, okay? I'm gonna give you guys 1 minute. See if you can find the solution for this. And if you guys don't know how to do it at all, if you're like, man, I don't even know what the crap this thing is saying, don't worry about it, okay? Just try it, please. And then let's compare and we'll go over it to see how to do it, okay? But take 1 minute to do that. Go. Now, with evaluating expressions like this, now it told us, right? Like, if we didn't see this bottom part right here, right? Whoops. Remove that there. Like, if we had just seen this and it said evaluate, it's like, well, what am I evaluating here? I mean, we have the expression 3 times c to the power of 2 times d. And this is something we should emphasize as well, is there is multiplication between each of these. I guess we could call them bases, right? Because we do have an exponent there. But it is multiplication, but without knowing what c and d is, we can't really evaluate it. So, of course, they've given us those two values. Now, since it gave us that expression, I'm just going to rewrite it as it is. And if you like to see the multiplication between those, you can do it. It's not necessary that you do. But it says right here that c is -3. So I'm going to replace c with -3. And then it says here that d equals -7. So instead of a d, I can represent it with that value of -7. So this is just straight multiplication at this point with the exponent, right? So we do have to still respect the order of operations. So -3 in parentheses to the power of 2 would show as -3 times -3, right? Now -3 times -3 is going to be +9. So just rewriting this expression, I got 3 times 9 times that -7. And at this point we can see from the multiplication, because there's no more exponents, that there's only one negative. And since 1 is odd, we know that this answer is going to end up being negative. And from here, I'm just looking to multiply from left to right. So I'd say, well, 3 times 9 is 27. And then multiply that by 7 will show the work. So 7 times 7 is multiplication. 7 times 7 is 49. We'll carry the 4. 2 times 7 is 14. Plus the 4 is 18. Now, of course, this came out as 189. I'm just showing it's positive. But going back to the negative part of that answer, right, we know it's negative. So the final answer on this is -189. Right, and again, we're emphasizing that the skill in this section is replacing letters with values. Now, right now, these letters are given to us, so we wouldn't even necessarily call them unknowns or variables necessarily. But they're placeholders for values, right? Like, eventually what we want you guys to be able to do is to write your own expression like this for whatever given situation, whether it's even in math class or in life, generally speaking, and say, well, I can write an equation for this. I know not everyone does, okay? But I can write my own equation for this, and I can figure out any answer for any given value, right? Like you could say, you could compare this to how much you make at work. Well, if you get paid, we'll just do something easy, $10 an hour. Well, if I work 30 hours, then I'd make $300. If I work 40 hours, then I'd make $400. Then you should be able to figure out, based on that equation, how much money you would make for any given number of hours. Even if you were to look at this problem and let's say that you forgot the parentheses, right? It would show us 3 times, and I'm really addressing this more for when we get into the calculators. So 3 times -3 to the power of 2 times -7. Without any parentheses, this only shows 2 negatives. which would make the answer positive. You'd still get 189, but your answer would be positive in that case. So with problems like this, when you have negatives, when you're replacing letters with negative values, I would always use parentheses, because now with the expansion of that exponent, you end up with 3 negatives. 3 is odd, which makes our answer a negative. Now, to further address that, right, if that 3 were positive, I would not need the parentheses. Now, just personally speaking, just because, and you guys have seen that I make mistakes, I would probably still use parentheses while showing my work. Now, again, if you were to use a calculator for this, which eventually we'll get into, right, not for Module 2, but for Module 3, is you would still use parentheses on the calculator. If you guys don't have a calculator that uses parentheses, it's outdated, okay? All right, so variables, I mean, they're unknown values. Sometimes they're unknown values that represent many different unknown values, okay? So we usually use x, but we saw in that last example that we don't always use x. I mean, you could use some other letter. In fact, some students choose to show emojis. I don't know how they draw them that fast, but I just like x. It's just 2 straight lines, bam, you're done, right? Try to avoid letters O, I, that's a lowercase l, and E. E is, it's a very special number in mathematics, and some teachers, like if you start using E, they start freaking out, okay? We'll still see it, but just know in other classes it may represent something else. Same with I even. But the O, it looks like a 0, and then the lowercase l, it looks like a 1. So try to avoid using those. Now, and again, sometimes they represent many values. Using and defining variables is a key feature in problem solving. So we talked about that already. Like, not that you have to, but you should be able to represent basic life situations with equations, especially when that things are changing consistently, like speed or distance, things like that, okay? Or amount you get paid at your work. Again, right now that may not seem very clear, but we'll see some word problems that'll help us to, hopefully they may be somewhat applicable, or that you can see how it would apply to what you do in life. And evaluating algebraic expressions, again, they're gonna show us those letters like we saw in the problem. What was it? 3c to the power of 2 times d. So we're gonna see those letters, but they for this section they're gonna have to tell us what number those letters represent. And then from there, you just replace the letters with the numbers. Again, if they're negative values, you're going to want to use parentheses. But otherwise, it's just straight evaluation from there, and then, or simplify. You could say it's simplification. But yeah, you got to replace the letters with the numbers that they give us. Now, eventually, what we want you to be able to do, again, if we were to apply this kind of to real life stuff, is to replace those letters with values of your own. So you're going to end up having to choose values for yourself. So a problem like this one, evaluate the following for the given values. This is 2 different problems. We'll do both of them. For x equals negative 12 and y equals negative 8. Yeah, well, we can do this one, right? So again, x is negative 12. So let's look at the top one. I'm going to replace the x with negative 12. And yeah, I put that in parentheses, right? And then the y, it says it is negative 8. I keep that sign in between them. And I can see right here I'm adding negatives, only negatives, so I know my answer is going to be negative. And from here, I would just take the big number, well, both numbers, just add them. 12 plus 8 is 20. So I keep that negative sign, and my final sum in this case is negative 20. Now, this next part is pretty good because usually we see problems like this on the quiz or test for what would be Module 2. It's subtracting those negatives, right? Because if I replace x with its value is negative 12, and the y value is negative 8, and the operation in this case is minus. Now, we don't usually minus negatives, we usually change that to a plus. And in this case, now I got negative 12 plus 8. Now, since I'm adding a positive in this case, or I'm adding two values with opposite signs, I can see that I have more negatives than positives being added. So I know my answer is negative. Now I just take the big number and subtract the small number. 12 minus 8 is 4. So my final answer there is negative 4. Now again, that may have seemed very basic, but remember, we're going to be adding more values, or we're going to make these look a little bit different as we go, okay? But if you can just even understand this basic concept of you're replacing letters with numbers, I mean, there's really almost no limit that you can go in terms of mathematics, okay? Like, what I'm saying is, if you can do this, you can pretty much do calculus. All right, so we can see, I mean, this one isn't just, we don't just, that says A, should say X, you guys. Typing's hard. So we're going to replace the X's with 5. You guys try these two out, and then we'll go over them, okay? We'll give you 1 minute. All right, hopefully you guys at least finish one of them, okay? But let's go over these. I'm going to give you the answers just so you can kind of check, okay? So that first one, you should have gotten 36. And the second one here, you should have gotten 8. But let's see how we get these, okay? So we can see that X is 5. So wherever I see X, I'm just going to replace with 5. In this case, we got it right there. So if I were to see this as a full expression, I'd have 2 times 5 to the power of 2 minus 14. Now, this has become an order of operations problem for us. And I'd have 5 to the power of 2. 5 times 5 is 25. So now I've got 2 times 25 minus 14, right? And I'll continue the work over here. So now I've got the multiplication. 2 times 25 is 50 minus the 14, right? Well, we can show it this way if we'd like. 50 minus 14, we'll make that a 10, borrow. 10 minus 4 is 6. 4 minus 1 is 3. And that is how we get that 36 right there. Next up here, again, I'm replacing the X with 5. And you can put it in parentheses if you'd like. But I'd have 5 minus that 3, and this is to the power of 3. So since I'm not really, I don't like that 5 in the parentheses, I don't have any exponents with it. I can just address it as 5. 5 minus 3 would be 2. So now I have 2 to the power of 3, which would be 2 times 2 times 2. And 2 times 2 is 4, times 2 is 8. So that's how we get that answer of 8 right there. That's why we want you guys to go through these, okay? Is even if you're like, man, I really don't know how to do this, please try it, because at the very least, you should find ways that you shouldn't do problems, okay? Because when you see problems like these on the quiz, usually even the ways that, like, man, I remember doing this incorrectly, those usually come up first before it's like, man, I need to do this correct, okay? So, again, we can learn from mistakes. We can learn how not to do things. Now, this one, it may seem really complicated, okay? But when we first look at this one, again, it's an eyesore. Like, man, I see exponents, I see parentheses. It's kind of long, and there's even words on this thing. I hate it, okay? Well, we may hate it initially, but remember what one of the purposes of the order of operations is to break big problems like this up into smaller, more manageable problems. So even though we see a problem like this one, hopefully you don't get too much anxiety, because we're not going to be focusing on everything at once, okay? Now, to get started, again, just for evaluating these, we need to replace letters with numbers, right? Because they tell us right here, x equals 7. So right here, you can replace x with 7. And again, you can put that in parentheses if you'd like. You don't really need to unless it's negative, which we see y is negative 2. So I'm going to replace y with negative 2. Now that I have these, I'm going to rewrite the full expression with these values. That y value was to the power of 2, so I got negative 2 to the power of 2. So this is rewritten, the expression. And again, that you guys may be like, well, Sal, your handwriting is horrible. Or you're like, man, it really just doesn't look the same. Okay, but the order of operations makes it so that it doesn't matter how I've written it, because I need to focus on each part of the order of operations one at a time. So again, we do have this big expression, but I would start with the parentheses. And right here, I'm looking for parentheses that have operations on the inside of the parentheses. So right here, I'm not even focusing on that 3 exponent. I'm just looking at 7 minus 5, which is 2. So I've evaluated that set of parentheses. I will rewrite the full expression now. Now, I'll keep this color-coded. That red negative 2 in parentheses, again, there's no operations on the inside, so I don't really have to look inside of it. It's just one single value. Now that I've evaluated that green set of parentheses, I can move to exponents. So I've got that 3 exponent and that 2 exponent. Again, we're only focusing on one at a time. So that green parentheses with the power of 3, that'd be 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So that evaluates to become 8. And now I'm looking at the negative 2 to the power of 2 in red there. So that's negative 2 times negative 2. And again, it's important that you show the parentheses with negative bases like we have with that y value. And negative 2 times negative 2 is 4. So again, rewriting this expression. So that's the exponents. We've taken care of all the exponents. I'm only focusing on multiplication or division from left to right now. Now there's 2 sets of multiplication. Okay, that black minus sign in the middle, I'm not concerned about it. But I am looking at the multiplication, and I'm only looking at it one set at a time. So again, I'm even within the operations, the order of operations, we're still breaking these up into smaller problems inside of each order. Okay, so negative 2 times 8, that's 1 negative, 1 is odd, so the answer is negative. 2 times 8 is 16. Okay, now I move to the next multiplication. 7 times 4 is 28. And this is subtraction between them, right? So I'm going to change this now. Instead of subtraction, I'm going to make it plus negative 28. And again, it's not required that you change it to plus a negative. I change it to plus a negative, not only because it's easier for me, but generally we understand what's going on when we see addition all the time, which we can. So I'm adding 2 negatives, which means that the sum is going to be even more negative. And we're going to take those values, 16 and 28, and we're just going to add them together. 6 plus 8, that should be 14. Carry the 1. 1 plus 1 plus 2, 4. So you can see how we've taken this big problem that we started with, and just by replacing the letters, maybe that even makes us feel better inside, because a lot of students, when we see those letters, we get a little bit of anxiety. Okay, we don't want that to happen. But we're just whittling this away small bits at a time, right? Like we start with this set of parentheses. Again, it narrows down until we should end up with one single value. All right, here's another, again, this one, a lot of students would look at this and be like, that's a pretty big problem, Sal. Okay, it shouldn't matter how big it is, because we're going to be breaking this up into smaller more manageable problems. So again, I would rewrite this. X to the power of 2 plus 6x plus 8 all over x minus 2. Now remember, with fractions like this, I can extend that line, you're just focusing on the numerator or denominator one at a time. Okay, so it's, even though we see a full fraction, we're not even focusing on the full fraction as we're going through this until pretty much the very end when we get to the division part of it. Now I've rewritten it with the x's. Remember, we're replacing all of the x's with the value of x that they gave us, which in this case is -2. So I'm going to go in and replace the x's with -2. And again, since I'm using a negative, I am using parentheses with that negative, which is going to be very crucial. Well, not only with the exponent, right? We got that -2 to the power of 2 in the numerator. But without the parentheses, 6 and -2, that would read as 6 minus 2. So we want to show that as 6 times -2, okay? So make sure you're doing that too. Now again, you could say, well, I can see the denominator is pretty easy to evaluate. All right, and you could if you wanted to. I just by habit, I focus solely on the numerator first, okay? Even though I can see that the denominator is an easier value to evaluate. So in the numerator, I got that -2 to the power of 2 plus 6 times -2 plus 8. I'm looking at that exponent because I don't have any operations inside of the parentheses. So I got -2 times -2. That's going to give me 4 right there. So rewriting the expression, now I got 4 plus 6 times that -2 plus 8. Now I can move to that multiplication part of that. 6 times -2, which is -12. So now I've got 4 plus -12, and then plus that 8 right there. So 4 plus -12, and yeah, you can use parentheses around that if you'd like. Again, I can see that would be negative. Particularly, we'll take 12 minus 4 because they're opposite signs, which is 8. And of course, we know that's a negative, right? So that would be a -8, which is now plus 8. All over something, right? Well, -8 plus 8, those are just opposites, which we're adding together, so we know that's 0. Now, from this, I mean, some of you guys are like, well, I already know the answer then. Okay, but just for the sake of doing these problems, because you won't always get a numerator that's 0, let's go through the denominator as well. Again, and we already know that's pretty easy value to get, right? We got -2 plus, or I'm sorry, -2, but I'm going to change it to plus -2. Now those are both negative, so I know the answer is negative, and 2 plus 2 is 4. So the denominator the whole time was -4. And this is something we should remember from Module 1 is the 0. If it's in the numerator, or if it's the dividend for a division problem, the answer to that is just simply 0. So again, the question for that division problem would be, and make sure I'm doing that right. How many -4s are in 0? There's none. So the answer to that is 0. When we evaluate expressions, it really just is the order of operations after you replace the letters with numbers. That's it, okay? And again, if you can get that down, I mean, there's almost no limit to how far you can go in mathematics. This skill is so important, and it's used so much. But a lot of students struggle with seeing the letters, and again, sometimes the brain just kind of gets things mixed up. Again, hopefully by doing this with the color coding, hopefully it kind of helps out a little bit too. All right, so we'll see some word problems like this one. Using the formula distance equals rate times time. Find the distance covered by an airplane flying 450 miles per hour for 4 hours. So we're looking for the distance on this one, and some of you may be familiar with this formula, D equals RT, or some students just say, well, it's dirt, okay, DRT. But we can see that up there at the top it says that the rate is the R value. Now a rate, even if we're not sure which of the values is the rate, you should be able to see, well, the time is going to be in hours in this case. So I can replace the T, time, with 4 hours. Okay, and that should tell us where the 450 goes. A rate is a comparison of two different quantities, which in this case is miles and hours. Miles per hour specifically. And we'll go over that in a later section of a different module. In a different module, okay? So the rate in this case is the speed of 450 miles per hour. Now miles per hour multiplied by hours, this is going to tell us the distance that this plane covered in those 4 hours. So I'd have 450 times 4, we'll show the multiplication for that. 4 times 0 is 0. 4 times 5 is 20, carry the 2. 4 times 4 is 16, plus the 2, 18. So this airplane flying 450 miles per hour for 4 hours is going to travel 1,800, and we do need a label for this one. This one is in miles